Hello everyone, in this video let's learn how to prove limit of sin s over s when s approaches 0 equals 1. Alright, so in order to prove this one, I'm going to use the unit circle. Alright, so the unit circle is a circle with the radius of 1, right? Now, suppose I have the angle theta in the standard position. Alright, so the terminal ray should be right here, right? Now I need to project down to find this side length, right? So how do I find this side length? I'm going to use the trigonometric ratio in the right triangle. This right triangle right here, right? So I have sine theta equals opposite over hypotenuse, right? Opposite, which means this guy right here. I call this one y, right? So y over hypotenuse is going to be 1, right? So it's going to be 1. So then y equals sine theta, right? So that's why you have the height right here equals sine theta. Now next one, I need to solve for this guy right here. So I apply the trigonometric ratio in this triangle again. So I have cosine theta is going to be adjacent over hypotenuse. Adjacent right here, I call this one s, is going to be s over 1, right? So s equals cosine theta, right? So this one equals cosine theta. So then the point right here has the coordinate cosine theta, sine theta, which is s and y, right? Now I'm going to create the right triangle right here. Alright, so I apply the trigonometric ratio in this triangle again. So I have tangent theta is going to be opposite over adjacent, right? Opposite in this situation, this guy right here, I call this is m, right? So it can be m over adjacent, which means the radius right here. I have 1, right? So then m equals tangent theta. So the height right here is tangent, which means the y value of this coordinate, right? Because s value equals 1 right here, right? So that's why you have tangent theta right here, right? Now I'm going to go back over here. You look at this one right here. This triangle right here. I'm going to print it over here. This guy right here. Okay. And then the sector right here. I print it over here. Alright. The last one is the triangle right here. I print it over here. Alright. So observe that the error of this guy right here always greater than equal to this guy. And the error of this guy always greater than equal to this guy. Right? Now you know that the error of the triangle is going to be 1/2 base times height, right? So I have 1/2 times base, which means 1, times height, the height right here, which means tangent theta, right? Greater than or equal to. The error of the sector is going to be 1/2 the radius square, which means 1 square, right? The radius is 1 right here. Times the angle theta right here is going to be theta, right? And then greater than the error of this triangle is going to be 1/2 times base times height, right? The base is 1 right here. And then the height is going to be sine theta right here. Alright, now I'm going to simplify this one. It turns out to be tangent theta over 2 greater than or equal to theta over 2 greater than or equal to sine theta over 2, right? Now you need to create sine s over s, right? So then I'm going to multiply 3 sine by 2 over sine theta. Alright, so what do we have? 2 and 2 cancel out. Tangent theta is going to be sine theta over cosine theta, right? So I just write sine over cosine, right? So this guy cancel out, right? So I only have 1 over cosine theta left, right? Greater than or equal to this guy cancel out. I have theta over sine theta, right? greater than or equal to this guy cancel out, this guy cancel out, it's gonna be 1, right? Now you need to take reciprocals of 3 sides of this compound inequality, right? Because you need this guy right here, right? Then don't forget to reverse the inequality symbol, right? So this guy greater than or equal to becomes less than or equal to. This guy becomes less than or equal to, right? Now theta over sine theta becomes sine theta over theta, right? This guy becomes 1, and this guy becomes cosine theta, right? Now I need to take limit 3 sides when theta approaches 0, right? So I have, now when theta approaches 0, cosine theta approaches 1, right? So I have 1 less than or equal to limit of sine theta over theta when theta approaches 0 less than or equal to, this one is the constant, right? So it's going to be 1, right? So then limit of sine theta over theta when theta approaches 0 equals 1 by the squeeze theorem, right? And this finishes the proof. If you have another way to prove this limit, please leave a comment, and it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand in mine.